Yesterday, we talked about the Pythagorean theorem and that if you have a right triangle, you can use a squared plus b squared equals c squared to find one of the missing sides, right? Okay, so if a triangle is a right triangle, then use Pythagorean theorem. Oops, let's spell it right. Find missing side. So that's what we did yesterday. So today we're going to flip this around. We are now going to take a triangle that I don't know if it's a right triangle or not, but I'm going to use the Pythagorean theorem to check it. Okay. So the converse of that would say if, well, not exactly of that because I'm switching what we're doing a little bit. So let's say converse of the Pythagorean theorem. If a squared plus b squared really does equal c squared, so if you have three sides of a triangle and they fit the Pythagorean theorem, so in other words, when you plug in the numbers, a squared plus b squared really does equal c squared, that means that you must have a right triangle. So this can be very, very helpful, especially if you are trying to, prove that something is perpendicular, or you're trying to prove that you have a right angle. You can use the converse of the Pythagorean theorem. So here's how it works. I'm going to take some random triangle, and I don't know if it's a right triangle or not. It doesn't have any angles marked as 90. And remember, we never go off of looks. Well, actually, I'll draw it so it looks a little bit more realistic. But you never go off of looks. You just go off of the numbers. So let's give one that looks, oh my gosh, that's even worse. Good thing these markers are erasable. All right, say I have this. Maybe it's a right triangle, maybe it's not. I have no idea. So one way I can check it is by measuring the three sides, and let's just pretend that the three sides came out to be, oh, I don't know, how about 6, 8, and 10. So what I can do is I can pop these numbers in for A, B, and C and see if the Pythagorean theorem holds. And if it does, then this has to be a right triangle. Wow. All right, well, let's try it. Now, similarly to when you know that it's a right triangle, you still have to put in the hypotenuse for C. So out of the three, you have to go with the largest one to be C. All right, so that still has to be true. A and B still don't matter as long as it's either of the other two. So I'll just call you A and I'll call you B. So just make sure that you are putting the largest value in for C. Sometimes they're not even going to give you a diagram too. They don't need to. They could just list the numbers. They could just say, hey, the three sides are 6, 8, and 10. You need to just put 10 in for C. So let's put a star here and just say, make sure you put the largest number in for C. So now I'm just going to take a squared plus b squared, and I'm actually going to put a little, oh, no, I'll do that in the next step. I like to do this when I plug in all my numbers. A, I'm calling 8. So I do 8 squared plus b is 6, so 6 squared. And right here, I like to put a question mark over the equal sign because I don't know if it's equal yet. I'm trying to find out if it is. So let's see, C is 10. So I'm just checking if this actually works. So let's see, 8 squared is 64. 6 squared is 36. 10 squared is 100. Is 64 and 36 added together really 100? Well, it is. So because this is true, that means that this triangle had to have been a right triangle.
Thank you.
So now we know, even though I did not have a, I didn't have a protractor, I didn't measure that this was a 90-degree angle, but I can prove that it is because the three numbers adhere to the Pythagorean theorem. Wow. Is it always going to work? No, of course not, because you're going to have plenty of triangles that look like they could be right triangles, but they end up not being. So let's try another one. I'm going to zoom down a little bit. Let's say we did one like this. And this time I told you the sides were, let's do 3, 4, 6. Okay. Oh, why did I put a right angle there? I don't know that it's a right angle, silly goose. What am I thinking? Okay, so I have this random triangle. Those are my three side lengths, 6, 4, and 3. So if I want to test, is this a right triangle? I have to pop it in and see what I think. So again, you have to figure out who's going to be A, B, and C. The only one that really matters is C, and it's got to be the biggest one. So in this case, it's got to be 6. So 6 is going to go in for C, and then A and B don't really matter. So when I plug everything in, I'm going to get 4 squared plus 3 squared, and then I'm questioning if it's equal to 6 squared. Well, let's see. If I do 4 squared, that's 16. 3 squared is 9. Is that in fact equal to 6 squared, which is 36? Well, this time it's a no, because 16 and 9 is only 25. And 25 does not equal 36. So this means that this thing cannot be a right triangle. And it's just that easy. The only way it gets harder is if we start throwing in like these numbers are a little bit more complex, like they're a decimal or something. But I mean, that's the premise. Just make sure you're putting the biggest one in as C and then checking if it works or doesn't work. All right, so let me give you some to try. All right, so we're trying to determine, is it a right triangle? So I'm going to give you a whole bunch. And you know what? I don't even think, well, all right. Some of them I'll draw you a triangle, but you don't even need it. Let's say I had 1, 2, and 3. Okay, so I have 6 here for you to try. Some I gave you the picture, some I didn't. You don't need to picture those. So give it a shot. I will be calling on you at random after a minute or so, or 2, or I don't know. I'll give you a little time to try these 6. And you're going to tell me if it's a right triangle or not. Oops. Okay, we've got some answers. Okay, let's try. So let me get my popsicle sticks here. I've already mixed them back together, so if I already called on you, you might get called again. We'll see. So for the very first triangle, did you determine that that was a right triangle or not? Caden, what'd you say for that one?
I didn't get to that one yet.
Number 1, really? Awesome. Cool. Okay, great. Olivia, number 1. Olivia, you there? You are there. Oh, sorry. I'm just looking for yes or no. Is all I need. Okay, so number one should be a no. Let's talk about why. C has to be 3. So you got to put that one in for the hypotenuse. A and B don't really matter. I'll call you A, I'll call you B. So when you pop these 3 things in, I'm going to zoom in a bit here so we can see it more clearly. All right, so if I'm doing this one, A squared is going to be 1 squared, B squared, 2 squared, and I'm going to check if that is equal to C squared. So now I'm just going to check the math. 1 squared is 1, 2 squared is 4, 3 squared, however, is 9. 1 plus 4 is 5. That does not equal 9. So no, this is not a right triangle. Okay, so the answer to number 1 should have been a no. I'm very confident that all of you can do this. You just have to do it. The second one. What is your answer here? Let's see, who gets this one? James, yes or no, is this a right triangle? James, what do you say? If you're talking, I can't hear you. You can put it in the chat if that's easier. I see you're unmuted, but I'm not hearing anything.
Sorry for the interruption again. One more announcement, all underclassmen. If your family ordered a portrait package from Les Gardner and you haven't been to the auditorium yet, come to the auditorium now to have your portrait taken. Again, if your family ordered a portrait package from Les Gardner and you haven't been called yet, please go to the auditorium now. Thank you.
All right, James, I guess you're not going to give me an answer. I don't know. What's up? Mark, is this one a right triangle, yes or no?
Good, no.
I'm going to have to disagree with you on that one. All right, guys, check it out. This one's got to go in for C because it's the biggest side. A and B don't matter. Call this one A, call this one B. If you swapped it, not a big deal. And then we're just plugging it into Pythagorean theorem and seeing if it works. All right, so please, everybody, pay attention, because once you get this, you'll find that it is very easy. But if you are not paying any attention, you're not going to know what's going on. So A is going to be 5. B in this case is 12. And then C has to be 13. So even if you had swapped A and B, it doesn't matter because we're just going to add them together. 5 squared is 25. 12 squared is 144. And 13 squared, oh, I like to put my little question marks because I don't know if it's equal to each other yet or not. 13 squared is 169, right? 13 times 13. So if you add 25 and 144 together, well, it just so happens that you do get 169. So since these two are equal, this is a right triangle. So that one does work. Number 3. I did not draw you a picture, but you don't need one. You're still going to pop these numbers in for A, B, and C and test the Pythagorean theorem and see if it holds. What did you get as an answer? Ethan's not here, so he can't answer. But Megan can. Did you get that this is a right triangle, yes or no?
Yes.
Yes, thank you. And you are correct. This is a right triangle. 17 is my biggest number, so that one has to go in for C, and then I might as well just say that one's A and that one's B. Don't automatically think that the last number is the biggest. Sometimes kids always fall into that trap that I like. Yes, these are in order this time, but I don't always put them in order. So just make sure you're looking. It's not always the last number. It frequently is, but it won't always be. Now you just pop it into the Pythagorean theorem. So is 8 squared plus 15 squared, does that really equal 17 squared? Well, let's see. 8 squared is 64, 15 squared is 225, and 17 squared is, I don't know that one. 17 squared is 289. So now I'm just checking, is 64 and 225 289? And guess what? It is. So because it really is equal, that means that yes, I do have a right triangle here. All right, number 4. Same idea. What's your answer this time for 10, 11, 12? Does that form a right triangle? Haley, would you say?
Say me?
What'd you say?
What, number 4?
4. Yep, I want yes or no if it's a right triangle.
No.
I agree. This is a no. I'll put that in for A, B, and 12 has to be C because it's the biggest one. So you're just going to quickly check, is 10 squared plus 11 squared, does that equal 12 squared? And you will see this time it does not. You get 100, 121, and 12 squared is 144. 100 and 121 is 221, which does not equal 144, which means that this cannot form a right triangle. Number 5 is a gift because you don't even have to do any math for this one. If you just think about it for a minute, you already know the answer. So, Colin, what was your answer to number 5?
Was it's 6. Hold on. I just need to go on my calculator.
Okay.
No.
Correct. This is not a right triangle. You don't even have to do the math on this one, honestly. If you recognize, think about it. If all 3 sides are 8, the only triangle this could be is an equilateral triangle. And we already know that equilateral triangles, all the angles are 60, aren't they? If all 3 sides are the same, then all 3 angles are the same. So this can't be a right triangle. But if you put it into the Pythagorean theorem, it's not going to check anyway. So if it's equilateral, no way is it right. And this last one, I would have to do the numbers here. And, you know, all right, so they're decimals, but big deal. We have a calculator, so we should be able to do it still just fine. So I'm just going to check, is 2.7 squared plus 3.9 squared, does that in fact equal 4 squared? I have no idea. So I just asked Mr. Calculator for some help. 2.7 squared is 7.29. 3.9 squared is 15.21. And I do know that 4 squared is 16. And I can already tell you that it's not going to be equal. But let's see what they what I do get. 7.29 added to that, 22.5. So this certainly does not equal each other. So this cannot form a right triangle. So that one is a no. Oh, the last one was a no too. I didn't actually write it though. No. All right, guys. So that's pretty much it. I do want to show you one little thing that can save you a whole bunch of time. And it's called a Pythagorean Triple. So I'm just going to show this to you really quick. You don't have to use this, but it's so convenient and fast. Are you kidding? My camera needs to be reset again. So Pythagorean triples. These are 3 sides of a right triangle that are whole numbers and work. So what's really kind of cool about them is once you find them, you automatically know if it's a right triangle or not, just based off of the numbers. So I'm only going to show you, like, really there's one that you have to know because it's so easy and it comes up all the time. So your easiest Pythagorean triple is this one. The 3, 4, 5 triangle. If you have a triangle with the side lengths 3, 4, 5, that makes a right triangle. It's the easiest one. 3, 4, 5. Check it out. 3 squared plus 4 squared really does equal 5 squared. 9 plus 16 is 25. So that means in the future, anytime I give you a problem and I say, hey, does 3, 4, 5 make a right triangle? You automatically know it's a yes. And I know you might be thinking, yeah, well, you're not going to ask me that often. You're right. You might only see it every now and again. But here's what's so cool about this. If you take a Pythagorean triple and you double it or triple it or quadruple it, you get a new Pythagorean triple. So what I mean by that is if you take a new triangle and I said, okay, oh, pretend I don't know that it's a right triangle yet. So if I took the 3, 4, 5 triangle and I just doubled each side, so I got 6, 8, 10. If you recognize, oh, hey, that's just a 3, 4, 5 triangle doubled, it's automatically going to work. What? There's no way that works. Yes, watch. 6 squared plus 8 squared really does equal 10 squared. 36, 64, 100. 100 equals 100. If I took the 3 sides, the 3, 4, 5, and I don't know, pick a number. Do you want to multiply them by 5? Sure. So if I multiply all 3 sides by 5, that would get me 15, 20, 25. That's going to work. No way. That works. 15 squared, 20 squared, 25 squared. Let's see. 15 squared is 225. 20 squared is 400. And 25, oops, that should be an equal sign. 25 squared is 625. No way. Way. That's so neat. So 3, 4, 5 is what we refer to as a Pythagorean triple. And you can just take them, double them, triple them, quadruple them, times them by 10. So if you're doing a problem and you recognize, oh, look, that's just a 3, 4, 5 triangle. She just double, or what did I do to this one? I multiplied them all by 5, right? So that, I mean, if you happen to, especially if I did like a 30, 40, 50, you're like, oh yeah, she just multiplied them all by 10. So it can save you a lot of time. This does pop up a ton. You start to see it over and over and over again. It's either this one or some version of it. There are other Pythagorean triples, but they're a little bit more, like, they're not as nice. There's no other ones that are 3 in a row like 3, 4, 5 is. That's the only one that's 3 in a row. The other ones are like we had up here. 5, 12, 13 is another one, right? So that worked out nice. Those are all 3 nice numbers, but those are harder numbers to remember. 5, 12, 13. Yeah, so I mean, if you can remember them, and then if you doubled all these sides, 10, 26, 24, that would make another right triangle. But that one's harder. So 3, 4, 5, though, that one's worth knowing about, and because you'll see them. So this will save you lots and lots of time on your homework, on your upcoming test on Friday. So whenever you see a 3, 4, 5 or a multiple of 3, 4, 5, you know it's got to be a right triangle. All right, cool. So that is it for the notes today. I am going to take a look at your homework, which is on Delta today. So it should already be live. So if you are confident and ready to go, then go ahead and try it. I will jump over there and do at least 1 or 2 of them out for anybody that needs additional help, and so that we have it on the video. Okay, let's see here. Let's see, B block, and is it live? Yes, it is. Oh, and you only have to do 6? Wow, that's so nice of me. Well, I guess if you can do 6 of them, then you should be able to do 100 of them, right? So why give you more for no reason? So 6.6b, is this a right triangle? So we're going to come in here and let's see. So they are oh, that's right. That's why I gave you so few, because for some of these, you're going to have to do a bunch of them. So I was like, oh, that's kind of annoying. I don't want to give you too many. So you only have 6 problems to do. Which of the following sets of numbers could represent the 3 sides of a right triangle? So I just need to check them really quick. Let's see. 42 squared plus 55 squared. That gets me 4,789. Let me see what 70 squared is. Not the same thing. So I know that choice A, or whatever choice you want to call this first one, that one can't be right. So this is going to be a little heavy on the calculator, this assignment. But it shouldn't be too bad. So then I'll try this next one. So on my calculator, this is what I'm typing in. 30 squared plus 39 squared. I get an answer that's 2,421. And I already know that 50 squared is not that. No, not even close. So that one is out. So now I try the next one. 24 squared plus 45 squared. And then I just see what 51 squared is. And hey, what do you know? That one works. So it's got to be that third choice for me. All right, submit. Let's try the next one. This one wants to know which one could not be the 3 sides. So be careful. And look what I noticed right here. That is a 3, 4, 5 all times by 5. So I already know that that's a right triangle. So see, if when you start to notice them, that'll save you time. I don't even have to test that one because I know that one is a right triangle. So let me see. I'm looking for the one that doesn't work. So let's try 20 squared plus 21 squared. That gets me 841. What is 28 squared? Yeah, this did not work. So that should be my answer. Yeah, cool. All right. So that's it. That's all you got to do for the homework. There's 6 of them. Just make sure you're paying attention to whether it says does or does not form a right triangle. So let me just check this one real quick. I'm just scanning if I see any of the 3, 4, 5 triangles, and I don't in this case. But I want the one that doesn't work. I actually have I'm pretty sure it's that one. Let's check. 8 squared plus 14 squared. And then 17 squared. Yep, that one does not work. So that is my right answer. So I'm going with that one. How did I know? I knew because there's another Pythagorean triple that's 8. Is it 8, 15, 17? I think that's it. I think it's 8, 15, 17. Yeah. So I knew that if 8, 15, 17 is a right triangle, then 8, 14, 17 can't be. But anyway, does anybody have any questions? Are you sure? All right, so we should be, let me stop this here.